And we're live. Hello? I don't see us on YouTube yet. Connect your encoder to go live. I think I've done that. Is anyone there? Click the live button. Live, and there we go. Welcome everyone. So tonight I thought, hey, goal. I thought maybe LSP improvements. Let's be more specific. Whoops. Move this, not that. How do I do this? When I press undo, it doesn't undo the thing I just did. Let's hide everything except for this. Nope, arrow keys don't work. Motherfucker. I'm trying to just move this goal text. I don't think it's locked. What if I lock everything else? Maybe I should just share OBS so you guys can see when the world is happening. I think it's just broken. Yeah, it's just not. There we go. I fixed it. Maybe actually, hover. Go to definition, LSP improvements, maybe go to definition. It's weird. I saved the file, but it didn't show up. All right. First thing I want to do is comments are not registered as comments. And the reason is because they're no longer tokens. Comments are now, parse doesn't have trivia, maybe in the lecture. Comments are now trivia. And I guess a token's trivia comes before it. Yeah. So what we'd like to do is Yeah, get them registered. So if we go into the LSP main, the issue is that the LSP is not looking at the trivia. So here's the semantic tokens implementation, and we're in a bit of a Frankenstein, a bit of a hybrid state, because we currently we grab tokens from, we do some of our highlighting based on tokens and some based on parsing, but we really want to do it all based on parsing. This is semantic tokens. This these all come from lexing. So if I shut that down, let me make sure, yeah, the stream's working. Shut that down. And now LSP. And this should build the LSP and install it. Such that if I were to restart here, hopefully that's the new one. And we can see that it is, because you see how a lot less stuff is highlighted, because this is stuff that we haven't moved from the lexer-based to the parser-based highlighting. So that's good. For example, the fun keywords, I think, and let. So I'm wondering if I want to keep some of it based off the lexer, because highlighting those from the parser is going to be a little burdensome, but also we have a bit of a higher ceiling for what we can do if we do it from the parser. So let's just do it. It's not that much. So the way this works is semantic tokens. Semantic tokens. So the parser will explicitly well, hello. Right. We'll explicitly add semantic tokens only if the LSP is enabled. As it goes. So it's different than the AST, right? The thing about the AST is it doesn't contain, like, the function node doesn't give a shit about the span of the fun keyword. So rather than like polluting the AST with tons and tons of subspans, I just say like, hey, if tooling is enabled and the reason we're parsing this is because we're the LSP, then let's just do that, right? Hope that makes sense. We just explicitly report them and then explicitly iterate them. So let's definition. Whoops, let's do a function for warm up. Okay. Here's the fun keyword. And, oh. Huh, we're adding the function name. That's cool. Right, so that's all it takes. And then the parens we could do as operators. I kind of like leaving them as the default color, and we'll save really meaningful things for the like we'll make this $sign an operator, right? Do I have operator yet? No. So this is kind of fun because it's completely up to me. And then the LSP is trivial. The other language server is trivial. So fun keyword. And it's fine to report these even if we're ultimately going to fail to parse the function, because, I mean, who cares, right? We'll still get better highlighting on failed parses, so it's like just better. That's enough that we could try to see the proof of concept, to get one win. Right, we have a problem. I think there is, yeah, an operator. Try that again. And now FN is highlighted with that weird blue. Let's do the dollar. Okay, that's neat. Let's do let. Oh, let's do NS. Oh, we already have it? No, it's something else. How is NS done? Is it actually namespace? Yeah, there actually is one for namespace. Okay, that's fine. It means that inside of these idents, for every Q ident we do, we could do namespaced ident. Every component of the namespaced ident we could treat. I think we're highlighting it as a function though, but we could do better. Right, function. So this is blue because we know it's a function call. The semis could be operators. Let's grab the keyword for and let. Right? And again, like this feels tedious, but I think it's very solid approach because it's going to maintain really easily and it's so explicit. It doesn't have a lot of like dependencies on other things. So it's just sort of a one-time cost of going through. Yep. Keyword let. Statement. Right. Use. Let's go ahead and do let. Okay. Let for, we didn't do the semis. If I'm in a block, problem is now we don't know what it is. Every time I find the delimiter, I could give it a kind. I don't know that I really need that to be an operator though. Like we don't need to highlight everything. In fact, I feel like we've already, I feel like most tooling should highlight less stuff. Like, I don't know what each of these colors mean. I actually know that this weird, very faded gray means a parameter, an actual parameter in this theme, but usually it's just very random. Like, here we go. We got let, we got for. Yeah, I mean, it feels like these should be different, right? Like the equal sign. Go back to the let and get that equal sign. colon. We could put it in here, right? Some helpers. Expect kind, semantic or something. Let's just say it's an operator. I don't know. And now it is. It's that more faded gray. Okay. But right. So that's because we turned off. This is weird because this is also a call. But it's method call. Method calls don't have it. Let's highlight calls. That seems fine. Is method true? Is method false? Is method false? This one looks like the main method call thing. How do I know it's naked? I don't know if this is really right. Name. Let's actually target. Okay. Again, I don't know if it's right to use the function token for these because I might prefer to use like the namespace token for these and the function token just for this. And like to use a different thing, like just the function name part. Right. Oh, this is just the function name part though. That's kind of handy. But for for these calls, I'm adding it to the whole namespace ident. That's the problem. I think it should just actually be first. No, not first. It's last. Oh, we don't capture the name span. Bit of a hack here, but I want to get this to work. Let's try that. Yep, that's better. Function names are blue. They kind of stand out. I don't know what the point of this is. Highlighting the comments would be good. So now that this is a lot simpler, because we're not doing any of this, yeah, the type stuff. So I'm going to do a similar approach for hover. In the semantic layer, I'll do the same thing. I'm just going to emit hoverables. you know, or like toolables. And then, so every time I like type check something that is hoverable or gotoable, I'll do the bookkeeping then. And then this will just be a simple lookup into those, which will be, I think, really nice and maintainable. But for now, we're here on, yep, we don't need that. We're going to sort them. So that works fine. And then we just need, oh, wait. I just got rid of all the Lexer stuff. But I actually want, I want the comments. So what I actually want Trivium? Uh-huh. Do we have trivia? Like, where's the trivia stored? Trivia pool, lex.spans.trivia pool. Okay. s.spans.trivia pool. I think it's git slice. Yep. Token trivia, token trivium. Okay. People usually make compilers in Rust, so that's what I'm currently learning and plan on writing my language in. Syntax aside, I am not sure the standard way to tokenize code. Yeah, I just like start looping over, iterating over the characters and do what you need to do. You know, typically just group things up into words and symbols, and, you know, I would say don't overcomplicate it. My tokenizer looks like this. If we avoid the fancy mode, we peak. So you basically just want you just want some notion of where you are, like a cursor, like this position here, and then your buffer you're parsing. So I use a slice of bytes, and you want peak and advance kind of, and yeah, we just peak, and if it's, let's go simple one. If it's open paren, we say it's an open paren. If it's closed paren, we say it's a closed paren. If it's double quote, we say, hey, we're doing strings now, and then you know, just kind of do the thing. And that's how you write a Lexer. They all start really simple, and then they only need to get as complex as they need to get. What's token trivia? It's got kind. White space, I don't think we even omit. So it's gonna be this. Okay. How do tokens point to store the data? How do you encode values like numbers or strings? That's a good question. I will tell you what I do. and what's usually done. What's the token type? Token types comment as U32. Just as soon as I span equal spans get. We need the actual span, not the span ID. Hopefully the sorting works. And that gets us tokens. So oh, look at that first try. Boom, boom. Something's up though. Look at that. Is it because it's not terminated yet? That works, but not while it's in flight. Whoa. I wonder what that's lexing as. Huh. Works fine here though. So many tokens have no data. Most tokens have no data. Some carry data like you've observed, like a number or a string, and you have some choices. You can give them payloads, like if you're using Rust, you can just do an enum, and like some of your tokens can be like unit variants, and then some of them can have payloads on them, and that's fine. And you could represent the numbers as strings and the strings as strings for the time being. Eventually, you'll want to do something like more efficient and smarter, and typically what's done is, if we go to my token, I do kind. These are a little interesting, but each of these enums only have 2 kinds. So really you can view this as just 4 kinds in one. It's not actually, there's not actually an infinite number of token kinds. Like there's really just 4 kinds of string and 4 kinds of string unterminated, because I do interpolation. But if we look at string, you see none of this shows the text, right? So the token kind is just the kind. And then a token has a kind and a span. And a span is a file ID, a start character, and a length. So that gives you your position. And then when you need the actual content of a token, you just go look back inside the source buffer at those characters. So you just index back into it. So when I don't even do it in the parser, I do it all the way in the typer. So for a string literal, by now I have a string ID. There's escaping to worry about. So here's the point though. By the time we're done lexing and we get to this string token, we just ask the parser for the characters of that token. So it's actually just like a read from the source code's buffer. And as long as your spans are like accurately talking about the locations, then that's the way to do it. The reason we have to build up a string here is because the exact thing in the source buffer is not the string we want, because it could have escapes. And we also do interpolation and other things. So we have to do more work. And then we build up a string, and eventually what we do is we push that string ID into our string pool, and then that's what the compiler uses the rest of the time to talk about that string. But the answer is you point to the source code. That's how your tokens carry data. They point to the source code. And then only once they transform it or do something different, then you just, like for example, once you know it's a int, then like you just carry a U64. But the thing you use to parse it is you just look at the source, parse it. That way you're not making copies of the same thing all over the place. Right, so it's already screwed up. Just after, yeah, any edits I make, maybe it's nothing to do with, no, it is the comments. Anytime there's a line comment. I bet I'm not clearing the trivia or something. Pending trivia. I thought about escaping, and the solution is just to make the reader do more work. Yeah, I'm not sure what you mean by the reader, but at some point, right? At some point, you're going to have the actual characters, you know, foo \n bar, right? And this is 1, 2, 3, 4, 5, 6, 7, 8 characters in the source code. And the string that you actually want to put into the binary is not all 8 of these, it's just 7, where this one is not this character at all, but is the actual new line character, right? So at some point, you have to do some string building where you replace the escaped characters with the one they represent. Yeah, typically you do that in the parser. So, but you can do it in the lexer too. But the thing is, lexers usually want to emit tokens, like just a buff of tokens, so they don't have a good place to store this information, like the parsed string or whatever. And it feels a bit more like parsing logic than lexing, processing what's in that string or parsing that number. I don't think I'm clearing the pending trivia, y'all. So every single token gets the same. To do, capture final pending trivia. Final trailing trivia. Okay, I'll make that a fix me. Yeah, whatever. When do I don't clear the mode stack. Pending trivia. Yeah. Thank you. I'll do something similar when I learn. Yeah. Once you have, I think you'll just find it natural if you just kind of, start, trying to directly do the thing you need to do. Rust can get in your way sometimes because it wants to get in your way with lifetimes and, the way it wants you to work with strings. But so in that sense, it's not the best choice, but it's also a great choice because it's just got a lot of things built in and a lot of tools for, it's very expressive. I think all of these go through make token. We're in my lexer now, by the way. Like I gotta fix a bug. Every time I emit a token, I attach the comments I saw before it as something called trivia, but I reuse that buffer because it's got to go fast, but I'm not clearing it. So we want to do this, and then we want to say pending trivia. Clear. And now, rebuild. Yeah, it's your lucky night. We're doing lexing parsing stuff. That's not right. It'd be state.trivia. So it's going to be lexer. Oh, man. Every eat token maybe then? Maybe it shouldn't even be in the state it's reused. Well, self.eat token is some. I don't really want to clear it in here. That feels gross. Make token, but this thing doesn't know about the state. Shit. Oh, okay. But this is kind of a waste because it happens on every token. And like, I know it's basically free, but I'd really love to do it only after I, oh no, it is. Yeah, it's fine. It should be nothing. Yeah, what does it cost to clear an empty vec and Rust? Like, how free is that? It's got to be pretty free, right? Self.len equals 0. Drop in place elms. I mean, there are no elms. So it does the right. It's gotta be nothing. Okay. I care because, you know, this is the Lexer, so we eat a lot of tokens. This is the most numerous thing we do. Like, there's so many more tokens than there are, like, nodes we parse, for example, that, you know, I care a little bit. I have spent a little bit of time optimizing this before. I made it 3 or 4 times faster last month. So I just want to make sure I don't do something dumb, but we should be fine here. All right, now let's see. That's feeling a little bit better. And then when we save, but now no one. Well, that's dumb. Now no one's getting the trivia. Yeah, basically nothing. It writes to self.len. Calls drop in place on a slice of length 0. I don't think we get to clear it here. Oh, this is so awkward for such a simple problem. It's just that because there's not one place that we produce it. Well, there is one place that we produce a token. Maybe I just need to pass the actual buffer into that instead of the slice. Yeah. All right, so we call it with nothing. I don't understand why we don't get any comment trivia. Might be time to move into our tests because I actually tested this. let trivia. This let has 2. I just didn't check that not everything else also has it. So that's not a token. If we're in line comment mode, line comment, right? When I see a line comment, oh, and then we return. That's why. Okay, we just push the pending trivia and then we return. So yeah, it's never gonna work. I think that, unfortunately, we're gonna have to do this. Well, I wonder if we can borrow it from the state. Very briefly. And that's the one place we need to do it for realsies. And now I just have to ref mute. Aha. This thing doesn't use it, so I could do it as an option. But like we know it's empty, so maybe it's just harmless. We know there's no trivia, but we can just pass it in anyway. This is a little bit unfortunately repetitive, but maybe small price to pay for something that touches every single token, you know? I wish it were drier, but I've already gone to some lengths to dry this up, right? I have a bunch of helpers for producing these tokens. Make from buffer, right? I already have make from buffer, but this one wants the kind. Maybe I could do make single. This one looks like return. No, it doesn't really matter. It's okay. Let's just like test. Oops. Nope, that's what that is. What does trivia mean for your token? Yeah, so there are things that are not tokens that you want to capture. Like white space and comments. And if you make them tokens, then you've got to complicate your parser significantly to ignore them. Like, yeah, white space and comments to ignore them, right? So what do? You strip them out, you make them tokens, then strip them out and hand that to the parser. That works. But then you want the version that has them. So now you got 2 token buffers, and that's like, okay. But it's also kind of imprecise. So what more mature parsers do is every token has preceding and trailing what they call trivia. It's unimportant stuff. And so my tokens have their line comments, the line comments that come before them as preceding trivia. So that's how my Lexer is able to capture the comments. And then also later the white space I'll do without mucking up the parser. It's a really nice way to do it. I used to have line comments as a token, but then I moved it to trivia. What it does is it lets you write a formatter because now you have all the information still needed to like reformat the code. You know exactly how many spaces the user put after their equal sign, right? You keep it all, but your parser still doesn't care about it. It's not working. Shit. Why not? Storing white spaces for reformatting, and I don't need to worry about it. Yeah, don't store white space. Just ignore it. Don't tokenize it. You don't even need to store comments. You can just ignore them. Or treat them as tokens and strip them out. That works for a while. See, this test is passing. So it's got this trivia here. So why doesn't the LSP pick it up? LSP log. Source.tokens. Is that the right source? Yeah, that's the source I was using. Asked for file. I gotta use the right asked. That might be why. I don't know, core asked, just to make sure we don't use it. Is that correct? I mean, I know that that's actually correct, but when we save it. Oh, that was it. I was using the wrong, yeah, looking in the wrong place. For both? For the saved version, it should have been working. It would have been the core asked if it wasn't edited, and then I would have been... I'm not sure. Anyway, what do we do? The only reason that's waiting is that's NeoVim's delay before calling the LSP again. So if we wanna watch term tail-f lsp.log, what's it called? K1 LSP star term tail-f K1 LSP. Check this out. Come on, actually tail it. Boom, boom. As you'll see, NeoVim sends a lot of requests. Does it work on a different token though? These are attached to this token, and it does. And this is attached to this token, and it shouldn't work at the end. It's the last token in the file, it doesn't work, but if there's something else below it, then it does work. Yep. There we go. Well, we did it. There's comments back in the LSP. That is not the main thing I wanted to do though. Fix trivia, add some new semantic tokens, and yeah, that's actually all that is. Let's test. Whoops. J-test. Cool. I wanted to do one cooler thing, which was what? Now that this is looking closer to how it was before, but with the benefit of the comments. Right. I was going to start to do like go-toables. What's something that's very go-toable? I'm going to go with well, function definitions are great. But those might get more complicated. A local variable would be nice, but they're so local, maybe it's not that helpful. Namespace is good. Let's do that. So we'll go into the typer, and we had semantic tokens. I'm going to do something kind of similar here. I'm going to call it like a because these things will have usage counts. Because like a function can be unused. You can find its references, right? Which is like find its usages, which is also how we'll do 0 usages. So for now, I think we might just be like pub enum like tooling symbol, searchable symbol, hoverable, discoverable thing at place, thing at spot. Likely, actually, it'll just point to the ID of the thing. Like for function, we'll point to the function, and that's the thing that's going to have usages and usage sites. Yeah, I don't want to say something like symbol. It's too generic. Like findable thing. Hoverable. Entity. This is like for LSP tooling. Namespace. We're going to start with namespace. So when we declare a namespace, we're going to go like, yeah, even if it's a redeclare. And then Where do we store these hoverable entities? We'll just put it down here. So it's like hoverable. And this could be by file. Yeah, hoverable entities. And we'll do it as a hash map by file. And for each file, it's just a flat vec. I think slicing it up by file is probably worth it. The other thing we could do is just sort them by file. What's the difference between enums and unit structs? Do you mean in Rust? RTMS man. The difference between enums and unit structs. Yeah. Well, an enum can have multiple variants. So you use it for expressing what's called a sum type, but I call it an either. You use it for expressing a type that's either one thing or another thing. So like either red, green, blue. This is like a Rust enum because it's one or the other. A unit struct in Rust, is that a struct that just has one? That's the thing where you have a struct with one member and you don't name it, right? They call those unit structs, which is kind of weird because it conflicts with what they call units. Or maybe they just call that a tuple struct. They call it a tuple struct with one member. But like you can think of a enum where the variants have no payloads as three unit structs, each with their own tag. But one is for expressing, from the examples I'm seeing, there's just the name, and you can set variables to it. Yeah, that's right. Enums without payloads, you're basically it's the same as an enum in any language. It's a name for a value. You're just kind of moving from a number to a symbol because it's easier to reason about. And, something, a color, in something of type enum color can only be red, green, or blue. It's not like some mix of them, like a struct would be with an RGB channel. It's about branching. Structs are about combining types together and multiplying their possibilities together. That's why they're called product types. And enums they're called sum types because they're about breaking them apart. Like a sum, 2 plus 2, we've split 4 into, 2 parts, 2 and 2. For now, I'm going to do it by file. We're fine to do a vec here because it's permanent. Okay. And this is no longer right. This is now hoverable entity kind. LSP entity? I just do that. Language entity? LS, language server. LS entity kind. Okay, so there's my enum. I only have one member, but soon I'm going to have another. Okay. And probably eventually that's going to store its function ID. And that's going to store its namespace ID. So we could like store these in some sort of fancy tree by span. But I think just a brute force search per file is gonna be plenty good. So we got a map of X. LS entities. Language server. Comes after phase. We should kill phase. LS entities. We just go too fast for the phase to matter. I don't know. How many files on average do you think will compile? 64, 128? It doesn't really matter because we're not pre-allocating the actual vec. It doesn't matter. For each file, we'll have to create one. We'll do it then. Oh, but actually, this. We'll pre-allocate if the LSP is on, else we'll do an empty one. Cool. I'm just gonna delete all this stuff. It was cool, but it didn't work. I'll do it again later. I can actually get it right. Ah! Yeah, y'all are public. And let's just make from the examples I'm seeing, there's just the name and like, oh, sorry, you already wrote that. You can set variables to it. Yeah. It really doesn't carry any more information than the name. But I have a mode on that shows you what the enum really is. It's actually showing you the value of the discriminant, but in this case, since I have no payloads, this literally just is. Namespace is actually just 0 and function is just 1. And if I put repr u8, well, actually I can't for that one, but. Okay. I just want to do this fun declare namespace. Self dot. Let's do it as a helper. Well, no, we'll do it. ls entities. I guess I have to be like entry file ID. Let's span self as spans get as namespace span of file ID. Okay. So for this file, or insert with. How many hoverable entities do we expect to find per file? We can start with like 128. That makes sense. Is that just mutate? Let mute. Geez. We'll pull this all out into a helper soon once it starts to take shape. It's a namespace. Might be best for these just to store their span instead of be the span ID. It's actually kind of slick. Right. So now we've like reported that like, hey, if you hover here, it's this namespace. And what's cool is you can read it. You can re-implement a namespace multiple times in K1. I can be like nsfoo fun stuff, right? I want a function for stuff, turns in it, and that's 33. And then later I could be like, you know what? We need to add more stuff to foo. We can do this. More stuff. Empty. And this one doesn't do anything. That is a really funny way to write an empty function, isn't it? I think it's the best we have, though. So both of these will point to that one. And I think that I'm done. Lex span. So that's the only place I use those. And then the idea would be to go into the LSP. And let's do our hover. Hover. And instead of the get expert at point thing, what I'm going to do instead is I'm going to say I need a file ID. I already did this. Okay, so we already have that. And then we could be like, if let some entities equals K1 ls entities get file ID. Okay. For entity and entities, if entity dot we need to do a span contains thing. Ouch. This madness. What are you building? LSP for your own language. Yes, LSP for our own language. This is Rust. This is the language. Look, garbage. It's actually 20 times faster than this. This is a debug build. What we did earlier in the stream is we made it recognize comments because that had been broken for a little bit because we changed how comments were parsed. We added some highlighting for a couple keywords. The coolest thing the LSP does, one of the cool things it does is this is a macro and it shows us what it expands to. And it actually saves the expanded code to a file. Sorry, make it bigger. So yeah, this is the language and the LSP we're working on. Yeah, unfortunately we need a no commit point in span reuse definition. We need a way to reuse this. But for now, let's think. If let some start line, K1 ask sources get lines for span, entity.span. Yeah. If start.line index equals line index, so we pass line in, get expert at point line index, but we pass in line, so I think that is 0 based. Let's hope so. I don't really know. If it's off by 1, we'll know. How long have you been working on this? 3 years, 2.5, 3 years, so a long time. The LSP is has only been a couple of evenings of work. It's actually really easy to do when your compiler's well organized. So it's a really small part of what the compiler does. The LSP really just runs the compiler and then inspects its state and data. Vector index absolute. Start jar, yeah, right. If span start, yeah. We'll definitely pull this out. Matching experts push. Instead, no, what we want to do is we want to say, okay, we're supposed to return hover contents. So I can just be like, return. See, the great thing about doing it this way is we don't have to do what the old code was doing, which is like find the smallest thing we parsed or type checked that is at this location. So we can return a hover, which needs a contents. Let's just copy it. A scalar. Marked string. Hover message is actually what this is. Let's just say it worked using ls entities. Hooray. I've never done rustlings. It thinks Canada is an international country. An international country. Line and call, I think. Because this one's calling, yeah, with line and call. And we're calling it char index. So I think that's fine. And this is just entity span, entity span. JLSP. So this rebuilds our LSP and reinstalls it in the place that the NeoVim plugin looks for it. And so now we restart, and what we did is if we hover on a namespace, we see that it worked. Where does that span end? It looks like it ends here. Oh, no, but not just inside. So oh, okay, we do. I guess we report all the way up to. Hover. So if we go to the parser, parsed namespace, what do we actually consider the span? Extend to here. Okay, this is what it is. The span of the namespace is actually this entire thing, but we're only checking the first line. And I made this a hoverable entity, which is fine, but it's actually not what I want to do. It's not the declaration side. It's every time we mention it, right? But I did the right thing. It would actually just be the name. And the name is an ident. Sadly, we don't have the name span. But I could put it on so that we have it. No, we'll just go to the start. I think that's good enough. So last thing we'll do tonight, let's actually, in the typer, let's actually emit the entity where we want to. Right, so this code we wrote is great. And then commit, put this in a good spot. And then this is just emit ls entity, language entity. I think we just want to do it like this. Span. We'll do the ID, which is nice. That'll save us some time. And the kind. Okay, so this code becomes emit. Oh, and the whole thing can be if CFG, can you do feature LSP? Do you remember? Yes, feature LSP. I want you to do what I had written here. I don't trust the clinker. Okay. We know the span. This is just the kind. See how that gets nice? It doesn't need to be mute because it's a reference. No else entity. So now this is just going to be ask namespace dot space span, but we don't even actually want to emit it here. It's actually every time that we resolve a namespace. So how would that be? Resolve namespace ident, qident. It's like, let's do resolve parsed call, right? Where's the right, in scopes, the part where we traverse namespace chain. Yeah. So it's actually way down in here, sadly. We would first lookup is special and recursive. Once we find it, we would emit the thing here. And then every time we find one, emitted there. I'm going to do it. I'm going to do it right here. The problem is this function is called from a number of places, but I think it makes for a good final task. I might just move it. It's also called from a number of places inside scopes. Really, this stuff needs to move out of scopes. It's not really helping us. Let's try though. It doesn't take anything mutably so far. Oh, it's gonna be tricky. I'm gonna do language server entities. We don't have a good type for that. It's actually a hash map. I think that's what it is. If only both scopes and the a whole module could just have a pointer to this thing, but no. Actually, I have half a mind to just do that. Because I already use, I already cheat the borrow checker in a few places. So what's one more place? Every time we find namespace, ls entities. I need the helper function too. Oh, this stinks. I need the function from over here, emit ls entity. I picked a tough one with namespaces. I need to just move all this scope stuff into the same file, or not the same file, but the same struct, and it'll be fine. Let's just do that. What all's on scopes? Some things, not much. 3 maps and 2 pools. I don't think we're ready for this. I need to factor some of the scope stuff out just for silly Rust borrow checking reasons. And then yeah, we would emit the entity every time we successfully resolve a namespace during traversal. And then what we would do is, this is a namespace. So then when we hovered on this, our new hover would take effect and we would know that it's the namespace. But the goal isn't really for hover, although it's nice because now we know we're hovering a namespace and we can do something really good here. Here I just know that it's a call because I'm doing the whole expression. And so then whatever we want to do for hover namespaces we could do. But the real value here is in goto definition, because now what we've done is we've hovered here and the compiler has told us, like, unambiguously, yep, that spot, that is this namespace, and here's its ID. And then we say, great. Where's that thing defined? Boom, we go to definition. Or, great, what are its usages? Well, every time we add one of these, we should also add a usage to the namespace. Or we could just traverse the discoverable entities. That could work too. But yeah, we're going to start to... everything in the compiler, you know, it's interested in compiling the code. It's not interested in answering the question, what is at this spot? Now, while we compile the code, we can easily populate a secondary index using these positions that answers the question, what was in that spot? But if we don't do it intentionally, we don't really end up having anything good like that. Like here, we actually have like 10 expressions that cover this span. There's this string, there's this interpolated expression, there's this variable literal, there's this call is also an expression, this block is an expression, and all of them share this token, right? So when I hover, I'm just taking the smallest one that overlaps and it kind of works. But really the best thing to do here would be for the compiler to say what's in that spot. So yeah, I hope that makes sense. For expressions, it's weird, and hovering expressions is something that like doesn't typically add a lot of value anyway. Usually you just want to know the type of it, which we kind of already have. So maybe expressions is a bad example because we'd want to continue doing that the way we're already doing it. But for symbols and entities like a type or a function name or a namespace, it's amazing, right? It's going to be great. But yeah, I got to move this stuff to another file, and then we got to do it. Namespaces and functions, I think, is a great first target. Yeah, I mean, on hover and namespace, I might as well just list all its definitions. That'll be great. I'm gonna make that a no commit, actually, like Man, on hover namespace, list its definitions. I think that's going to help me with some discoverability too, while the language is really young and undocumented. Okay, I got to wind down now. Thank you for watching, whether you watched tonight or are watching in the future. Yeah, happy coding.